How's it going, everybody, and welcome to Math with Corey. Today we're going to be looking at the average rate of change. Okay, we're going to use this formula in order to find the average rate of change. Okay, I'll walk you through two example problems and we'll be able to do this. So I just wanted to mention first that maybe sometimes you're given a table and asked to find the average rate of change, or maybe given a graph, you want to find the average rate of change, or even maybe within a word problem, right? You're asked to find the average rate of change. Regardless, you're going to want to use this formula here, okay? So this formula is going to be very important to us, okay? But why is average rate of change important? Why might it be useful to us? Well, if we look at two different graphs, this graph is of a straight line, okay? And this is more of a curve, right? Not a straight line, okay? If I were to ask you to find the rate of change or the slope from this point to this point, okay, on this straight line, you would say that's the change of y over the change of x, okay? So change of y, change of x. And from this point to this point, change of y, change of x. What you're going to find is the slope never changes. No matter what point I pick on this straight line, right, straight line, the slope is going to be the same, right? It's never going to change. So if that's the case, my average rate of change is going to be the same as the slope as any point on this line, right, on this straight line, or between any 2 points, right? The rate of change is going to be the same as the average rate of change. What do I mean by that? So if I were to tell you that the change of y over the change of x is going to be 4, and the change of y over the change of x is going to be 4, right? The slope of this line is going to be 4. My average rate of change is going to be 4. What do I mean? Well, let's say if you were to get an 86, right, on every exam that you took, right, your average for the class would be, well, 86, right? You've never gotten anything different. Same thing with this straight line. The slope is always going to be the same, so the average rate of change is just going to be the slope of that line. However, if we look at a line like this, right, more of a curve, okay, and we look at the slope of the tangent line to these points here, right, to each of these points, what you're going to see is it's getting steeper and steeper and steeper. The slope is constantly changing. And if the slope is constantly changing, it might be useful to find the average rate of change. What do I mean by that? Well, let's say you got an 86, and then you got a 96 on an exam, then you got a 72 on an exam, right? Then it's going to be quite useful to find your average, right, for those test scores, okay? Just like this, if my slope of the tangent line is constantly changing at each point, okay, it's going to be quite useful to find my average rate of change, all right? So let's run through these two problems here, and hopefully you'll get a better understanding of average rate of change and how to use this formula. Okay, so looking at number 1, it says f of x equals 3x plus 12, and I want to find the average rate of change from 5 to 8. Okay, well, looking at the formula, I need f of b, I need f of a, and I need b and a. All right, so let's look at a and b first. What should I make a and what should I make b? Well, a and b are going to be x values, okay? And I could say that this is going from a to b, right? From a to b. So I'm going to make a 5 and I'm going to make b 8, okay? So those are my x values, okay? Now I'm going to be looking at f of a, which in this case we have made 5, and I'm going to be looking at f of b, which in this case is 8. Okay, well, let's look at f of 5 first. That's going to be 3 times 5, because again, I'm just replacing x with 5. So 3 times 5 plus 12. Okay, so f of 5 equals 3 times 5 is 15 plus 12, 27. Okay, great. So f of 5 equals 27. F of 8 is going to be 3 times 8, okay? Just replacing x with 8 plus 12. So f of 8 equals 3 times 8, 24 plus 12, 36. Okay? So now I have a value for a, I have a value for b, I have a value for f of a, and I have a value for f of b. Okay? So now all I have to do, plug into this formula. So let me write it out. So now it's going to be f of 8, right, because it's f of b, minus f of 5 over b minus a, 8 minus 5. So this means I have f of 8. Well, f of 8 is 36, minus f of 5, 27, over 8 minus 5. 36 minus 27 is 9. 8 minus 5, 3. This equals 3. 9 over 3, 3. and that's my average rate of change. Now, if you were to look at this function here, and if you were to graph it, okay, this is in the form of y equals mx plus b. It's a straight line, okay, meaning it has a slope of m. And in this particular case, it has a slope of 3. As you could see, my average rate of change is the same as the slope of this line. Because why? Because it's a straight line, okay? If we look at number 2, it's going to be a little bit different because it is not a straight line, okay? So the average rate of change is definitely going to be useful for this one. Let's find number 2. All right, so number 2 says d of t equals negative 16t squared plus 50t plus 3. Okay, and I want to find the average rate of change. T equals 0, t equals 2. Okay, how can I do that? Well, again, we're going to use this formula. And don't get confused, just because we're using f and x here, and now we're using d and t, right? It's the same thing, same formula. So if I were to write this, it would be d of b, okay, minus d of a over b minus a, right? It's the same thing. Don't try not to get confused, right? We're just using different variables. It's the same idea though, okay? So again, I need a and I need b. A and b are going to be my t values, so it's going to go 0, 2. So a is going to be 0 and b is going to be 2. Okay, great. So now I need d of 0 and I need d of 2. Okay, so d of 0. So again, I'm just replacing t with 0. So negative 16 times 0 squared plus 50 times 0 plus 3. D of 0, oh, sorry about that, d of 0 equals. So 0 squared, 0, times negative 16, 0. 50 times 0, 0, plus 3. So the only thing that's going to be left over is that 3. So d of 0 equals 3. Now d of 2, okay, that's going to be negative 16 times 2 squared plus 50 times 2 plus 3, okay? All right, so d of t equals 2 squared is going to be 4 times negative 16 is negative 64, okay? 50 times 2 is 100, so plus 100 plus 3, okay? All right. And then that means that d of 2 equals, well, let's see. This is going to be 36 plus 3, 39. Okay? So now I have a value for A, I have a value for B, I have a value for d of A, and I have a value for d of B. Okay? Now I can just plug into my formula. Okay? So it's going to be d of 2 minus d of 0 over 2 minus 0. Okay, so d of 2 is 39 minus d of 0, 3, over 2 minus 0. Okay, so 39 minus 3 is 36, 2 minus 0, 2. So this equals 18. My average rate of change, okay, is 18. All right, so that's how you find the average rate of change, right? So as you can see, this formula here is very important, right, when you're trying to find the average rate of change. Okay, if you guys have any questions, leave it in the comments below. If you guys want to see any different type of math videos, let me know. All right, thank you for watching.